Welcome to the course Digital Transformation and Technological Innovation. So, we are into our second module, that is digital infrastructure. Likely this is the last session in that module. So, let us continue from where we left in the last session, right. So, we are talking about the operating system in different segments, whether it is about the single sphere of influence, single user sphere of influence, where we talked about Windows operating system and other operating Mac OS and other operating system. Then we talked about the the enterprise context, Windows Server, Unix, Linux that we discussed. Now we come to within the user segment, that is single user sphere of influence, right. There is mobile operating system which are very different from a PC operating system. So, now in this session we will go through some of those key differences, so mobile operating system and PC operating system. So, in terms of examples of mobile operating system, we have Android and iOS. So, they these two operating system pretty much cover much of the market for operating system, and smartphone devices also, Google and Android, Google and Apple, right. So, now we look at the PC OS, it is Windows that dominates, then Mac is also there and Linux is also there, right. So, if we look at mobile operating system as such and PC operating system, one important thing, or the first thing that we need to look at is the integration between apps and the OS, right. Because handheld devices, the way they are operated and the way we interact and the kind of experience that we get from a smartphone and the kind of experience that we get from PC or laptop, that is very different. And one reason is the integration that is there between the apps and the OS. So, if we look at the mobile operating system, the integration is more towards hardware. So, deep hardware integration and shallow inter-app. So, from app to app interaction is constrained, but shallow inter-app, but there is a more deep integration when it comes to hardware, right. For example, deep use of GPS, NFC, camera, biometrics. So, there are so many small hardware components that are there in smartphones, sensors are there, right, camera is there, biometrics, sensors are there, NFC, communication cards are there, GPS is also there, right, for location. So, there are so many small sensors and the components, hardware components that are there. So, because of that many apps would like to take that data, access to camera or biometrics for authentication, or camera for giving features which are based on camera, NFC for facilitating communication to nearby devices, and the GPS for location and location based services, right. So, smartphone apps, they need access to these hardware, and therefore deep hardware integration is observed in mobile operating system, while shallow interact, because there is so much of access that is given to apps in terms of hardware, but there is some users data that is also there. So, the operating system would not like to allow leakage of data from one app to another app, and therefore shallow interaction that is possible in case of mobile operating system. But if we look at the PC operating system, the whole scenario changes. In case of PC operating system, there is deep software integration. That means from one app to another app, the interaction is much easier, much smooth. And when we talk about the hardware, then there is a shallow hardware integration. So, why? Because the main focus is on CPU, GPU and peripherals, right. So, it is more about multitasking, many applications running at the same time and all that, and CPU, GPU catering to those kind of scenario. So, there is a deep software integrations, application to application interaction, but there is a shallow hardware. So, you do not want your hardware to be misused in a PC environment, right. And there is not much, most of the hardware components, they are actually part of the PC box itself, right. So, moving on, now let us look at different parameters and compare these. So, if we look at user interface, so in case of a mobile operating system, this is very app centric, and you will see simplified icons, and you will also see that apps applications typically they will take full screen, right. So, there would be full screen mode, apps will usually come to the full screen. So, essentially mobile operating system is very app centric, right, and you open an app, then app is very deeply integrated with hardware, whatever camera and other things that that app wants to use, that is well integrated. So, you are into that app only, you are not moving into any other app. So, that inter app thing is not there. But when you are in a PC operating system, this is Windows centric. So, there can be multiple windows and you can run different application, different windows, and therefore there can be interactions while multiple applications there. So, inter app thing interactions would also be supported. So, that is the case. So, multiple overlapping windows, complex menu items and taskbars. So, in case of user interface, PCOS is very Windows centric, multiple applications running at the same time. In case of mobile OS, app centric. So, a particular app is taking full screen and running at one time and having access to the hardware and all. Moving on, next is input method, right. So, we look at the mobile operating system, you will see that it is touch first, and therefore because people might be using fingers, swipes, or there could be multi gestures. So, all these options are there, and therefore it is touch first and optimized for that kind of input interaction that can be there in case of smartphones. Then if we look at the PCOS, then this is precision first. So, where you are how you are interacting with the computer, that is optimized for mouse, keyboard, and clicking, right. So, the clicking that you do through mouse. So, pixel perfect clicking. So, you click on something. So, accordingly it's a very precise the kind of interaction that you do in a PC environment. So, controlled by optimized for mouse and keyboard, and therefore pixel perfect clicking that you can perform. But in case of mobile operating system, touch first is there. So, optimization is that way. So, it is not obviously very precise. Now, we come to file system, right. So, in case of a file system, we compare these two operating system, mobile OS and PC OS. We see that in mobile OS abstraction is there, so files are hidden. So, apps only see their own folders, right. So, access the data privacy, so that can be there, because there are so many popular apps, and some apps they do not want to allow access to users data to some other apps, right. So, therefore, the operating system supports that kind of requirement. So, abstraction is there, apps only see their own folders, right, primarily, right. So, app level abstraction is there in a way when it comes to operating system, when it comes to file system in case of mobile operating system. If we look at the PC operating system, and the file system gives direct or slightly open access. So, apps can access broad directory trees. So, through apps you can actually browse through or access files which could be placed in so many different places. So, in terms of file system in case of PC operating system, quite direct and open access we observe in comparison to what we see in mobile OS, where it is app only kind of access. Moving on, next important criteria that we can consider is multitasking, right. So, in case of mobile operating system, you will see that there is a suspended state that is quite common. So, there would be lots of background apps, because you started an app and then you were doing something or not some time you spent, and then you moved on to another app. So, that app is still on, but then it there are limited resources. So, previous app that you were using, it will be pushed to a suspended state, right. So, background apps are often frozen, right, or limited to save battery, because the smartphones they for power they use battery which might have a limited life. You will have to recharge again, right. So, therefore, the operating system provides looks for that kind of eventuality, and therefore, any background apps it will put them into suspended state. And sometimes if you allow the notifications from the mobile operating system, then it will throw you those notifications as in some app is consuming a lot more battery, lot more power, and therefore, it will prompt you for stopping that app, right. So, that was about mobile operating systems. The multitasking is not very supported. So, background apps are there in a way suspended. If you look at the PC operating system, is concurrent. So, multitasking is totally supported. So, at the same time multiple processes can run, and we have earlier sessions also we have spoken about this, right. So, multiple processes run actively in the background with high CPU uses. The whole PC operating system is designed for that kind of fairness and giving giving CPU time to all the tasks, right. So concurrent execution of multiple processes is possible for PC OS. So therefore multitasking support is quite good in PC OS, but that is not the case with the mobile OS because of the issues that we talked about, for example power consumption, battery and other things. Then if we look at software source, in the sense how do you acquire software, how do you obtain or download software in a mobile operating system, and how do you do the same thing in case of PC operating system. So we notice very clear differences in this case, that there are curated stores for mobile operating systems. So what are these curated stores? We already know. If you are using iPhone, then this is Apple's App Store. If you are using Google Android devices, then it is Google Play Store, right. So it is more often than not it will be installed there. So curated store is installed there, and the kind of apps that you are supposed to obtain or install, you need to get them from these stores, right. So that is the case about mobile operating system, and these, whether it is about the App Store or Google's Play Store. So because there are so many smartphone devices that are either running Android or iOS, right. So therefore there are huge ecosystem of mobile app, smartphone app developers that have come up. So they are catering to so many apps for these smartphone devices, and those are listed through these curated stores. So much of the apps that could be relevant for your work, for your activity in mobile or smartphone or handheld devices, you can get them pretty much. You can get them from App Store or the Play Store. Coming back to the PC operating system, this is slightly open how you can source your software, because PC could be used for not just for the personal, they could also be used in office setting also. For example, we talked about the desktop and the workstations, right. So sourcing of software is slightly open, can be installed via the internet downloads, physical media, right, and repositories are also there. So depending on the operating system, whether Windows or Linux that we are using, different ways we can install the software. Now coming to the next differentiator, that is hardware architecture. So we look at mobile operating systems. Typically smartphones have the ARM processors, ARM architecture. So smartphones, mobile operating system with Android and iPhone, they would be optimized or they'll be supporting the ARM architecture or equivalent architecture, right. So designed for high efficiency, what this architecture is about. So ARM is designed for high efficiency and low heat in a small form factor. So smartphone is the handheld devices are the we can say in a way smallest form factors that are there, and therefore low heat, high efficiency, that kind of design, that kind of processing is needed. So ARM architecture is designed for that. So mobile OS are compliant with that kind of architecture, right. We look at the PC OS, it is more x86 or x64, so designed for raw performance, because multitasking, multiple applications, they could be running with good enough CPU utilization. So therefore optimized, designed for raw performance and high throughput, right, more number of tasks or jobs that you want your PC to complete. So Intel, AMD are the companies which provide this kind of architecture, x86, x64 kind of architecture, right. So there is clear differences in terms of hardware architecture that is there in mobile OS and PC OS, right. Moving on, we look at the security. So this is also very different. In the case of mobile operating system, we see sandboxing, which is not common in PC settings. So apps are isolated from each other and the system core, right. So earlier also in case of file system and other parameters we touched upon this. So sandboxing is done because you don't want to allow one app to access data of another. So how do you do that? So from security point of view also sandboxing is done, apps are isolated. If we look at the PC OS, it is more administrative. So end users or the admin users, they are given that privilege, and they can grant deep system level permission to software. So any software that is to be installed, the admin user can give access or deep permissions for different kind of software, right. So it is more administrative, but in case of mobile OS it is part of the OS itself and sandboxing is done, right. Moving on, if we look at the workflow, if we look at the workflow for these operating systems. So mobile OS, this is workflow is more like one off. So essentially you focus on one task, you focus on one app. So it's very focused, one off focused, and single task interactions is something that we see, right. So we are on to one app, so only that is being run. So one off kind of workflow we see. But if we look at the PC OS, interconnected workflow is there, multiple apps working together in Windows, right. So that multitasking kind of scenario comes in here in case of workflow also. These apps can be interconnected also, right, which is the supported by the typical PC operating system, right. More app to app interaction that is possible in case of PC operating system, but in case of mobile operating system that is not supported. So one off focused single task interaction that are supported by the mobile operating system. If we look at the next parameter, that is connectivity. So in case of mobile OS, there is native cellular, that is already native cellular kind of support that is already there. So integrated support in the sense 5G LTE support, GPS would be there, NFC would be there. So there are multiple communication technologies and the hardware support that is natively given in the device and that is used by the mobile operating system, right. So 5G LTE, that is for our internet data connection, GPS is also there, and NFC for nearby communications, transfer and exchange of data, right. If we look at the PC operating system, more often than not the kind of connectivity that we see is wired, which is fixed, or Wi-Fi, right. So primarily the PC, laptops or desktop workstation, they rely on Ethernet or Wi-Fi kind of connectivity, right. So there are also slight very clear differences, but mobile smartphones, because of the coverage of telecommunication services, so wide coverage is there, big regions and cities, villages, tier 2, tier 3 cities all are covered. So therefore using mobile, that portability comes in. So the kind of connectivity that is inbuilt or integrated in mobile operating systems, you have a computing device, with that you can go to any place, travel around, and you will be connected to internet. So some of the workload that you can do with the smartphone or handheld devices, and for that if you need internet connection, so that is feasible in case of mobile OS, right. Now we look at the power supply here. So in case of mobile OS, the battery optimized, because mostly battery is needed for power. So there would be aggressive sleep mode, so it would like to optimize. So if you are not using phone, it will go to sleep, right. Brightness management is also there again for the same purpose, right. So there would be options to auto manage this brightness also. But in case of PC, because it would be directly connected to the power, so there is a constant power supply that is likely to be there. So this is built to handle high wattage hardware and cooling fans and all that. So constant power supply and all that. So the power supply, and that is also very different here. Now moving on to another important aspect of digital infrastructure is that how do information systems they interact with each other, right. So next that we are discussing, there are so many information systems that we might have within a large organization. Their data and the processes that they support, right, and the kind of processing of information and data that happens. So how, if some kind of exchange is needed for that data information, how that is supported, right. So how do information systems interact with each other for that exchange of data information to happen between systems. So essentially system to system interaction, how that is facilitated. So let's look at that. So essentially we are talking about the interaction mechanisms between systems, right. So older technology that was quite common was the middleware. So what are middleware? Middleware themselves are software that serves as an interface between internal systems to exchange data and information. So middleware, for different systems you might have to use different middleware, or some middleware solutions they will be very comprehensive. They will provide support for very different kind of information systems or enterprise systems, right. Now the problem with this was that it's not reusable. because rigid custom design is there, because somebody has to look at the the kind of data information exchange that will happen between two information systems and come up with a software that will do the interfacing between those two requirements, and data exchange could happen, right. So therefore it could become very bespoke, it could become very peculiar, and therefore reusability for such solutions, middleware solution, will go down, right. So slowly we evolve towards a new tech or new approach rather, which is a service oriented architecture, SOA approach. So we moved away from middleware and more towards service oriented architecture or SOA approach. So what happens in service oriented architecture or SOA based systems, that typically the development of software is more modular. So modular application services are designed and developed in the systems. So they follow the service oriented architecture. So what it does, they allow users to interact with systems and also systems to interact with each other, because the services in the software has different modules, and these modules are acting like modular services, and therefore more interaction between these module to module interaction is feasible, and obviously users can also interact with different modules, because at one time they might interacting with the a task that is facilitated by a particular module, right. So designs for SOA based system typically adopt standards for interaction, right, and therefore interaction with the other modules is quite flexible, right. So flexible for systems to expand and evolve over time. So that flexibility is also there. New module can come in because the older one they are following standards for interaction with other SOA modules. So new modules can also join that, follow that same SOA approach, those standards, and therefore if you want to expand your systems, right, and the modules, so this SOA based approach is more flexible, it can be expanded, evolved, so more suitable, right, as the business grows or their needs or verticals grow. Reusable, because the modules are smaller components within a software, so therefore any module which is relevant in some other system, so it can be part of that. So reusability in similar context is also there, so higher reusability, so therefore reducing development time. So certain modules which were part of a particular system and they might also be needed in another information system, so that development time will get reduced. So modular, this SOA based approach not only facilitates the interaction between system and system, it also brings down the development time. Then moving on, what are different types of software product that we have, right. So businesses, they can actually purchase and use popular standardized software which will actually be matching their processing needs, right. So when they do that, so this kind of category is referred to as off the shelf software product, right. So some standardized software product is available directly in the market and you just go and buy that. So those are referred to as off the shelf software product. So why you buy that? Because they might be matching your desired processing needs, right. Now what are these off the shelf software products? So these are software produced by IT firms which are looking to address processing needs that are common, right, for across businesses, organizations, individuals. There are lots of such, for example email service or office products, right. So there are lots of software products which are very common across business organizations. Some of the IT firms, they come up with their software product which other organizations have those kind of processing need will just buy off the shelf. Next, another thing that is possible in case an organization wants that off the shelf software product because it is matching, let's say it's 80%, 90% of the need, but there is some differences. For some software products, some customization or configuration options are also supported by IT firms. So if that is the case, organization can go for that customization or configuration and therefore better match the processing needs that they have while just taking off the shelf software product, right. Now from this scenario we also can understand that IT firm can be playing one of these two roles or maybe hybrid role. One is independent software vendor, ISV. So independent software vendor is the one which came up with that software product we are talking about, off the shelf software product, because the common need was there. So independent software product will come up with that product, right? And then there is another one, managed service provider, MSP. But if the independent software vendor is not interested or not catering to a particular region in terms of providing customization configuration, then the managed service provider, MSP, they can come in and give that support in that regions, because they might be operating in that region, right? Or maybe the ISV, independent software vendor, might not be giving the customization configurations, support and all, ongoing support. So independent software vendor is essentially an IT firm that actually developed, owns and licenses the software. So they are also referred as product vendors. Examples are Microsoft, Salesforce, SAP. So they have their product, but there could be certain regions, certain geographies where they might not be providing ongoing support or customization or configuration support, right? So they are referred to as independent software vendor because they came up with that product which is matching the processing needs of many organizations. So they are buying these. Products. Now managed service provider fills this gap. So they provide the last mile services, right, on top of software product, on top of those popular software products. So these companies, managed service provider, they'll provide the last mile services. So they are typically referred to as consultancies or services vendor, IT services company or IT consultancy company. So this is how the terminology goes. So what they do, they offer installation, custom coding, integration, ongoing support, right? So in case an ISV is not catering to that, the MSP, which are like IT consultancy or IT services vendor, they will provide that. And the product vendor, sometimes they do that, sometimes they don't. So these are the two roles that different kind of IT firms play. Now there might be times when businesses can develop one of a kind program for a specific processing need. So they might be having a specific processing need which is not being matched by an existing software product, off the shelf software product. So they will go and develop one of a kind program to match their specific processing need. So it will be proprietary software product, right? It will be proprietary software product, and so one of a kind software designed and developed by the firm for its specific processing needs, right? Then there is another category that is referred to as software suite or software package. So the software package is a collection of programs packaged together in a bundle. So certain small software, small programs, they come together because they are the way professionals and other for personal use people work, right? So some of these programs might be needed together, might be used in conjunction, right? Or same set of profiles, people working in same sort of job profiles might be using it, right? So these can be bundled, right? So a collection of programs packaged together in a bundle. So one category within this is general purpose software suites for PCs. For example, Microsoft Office is there, which will contain a spreadsheet program, word processor, database program, presentation software. This is kind of bundling. So we call this like software package. So Microsoft Office is more of a software package. It is having collection of programs, and typically these will have a spreadsheet, word, and all these kind of programs. So this was about our this second module, digital infrastructure. In the next session we'll be starting our new module 3. Thank you.